let's move to the second part of this class. Let's move to the second part of this class, which is naming of alkanone. Naming of alkanone. Alkanone is also known as ketones. Then it has a general formula of RCOR. It has a general formula of RCOR. Then the functional group of alkanone, by the time you remove R at this side and at this side, so the functional group will be CO and a double bond. So this is the functional group of alkanone. Then under alkanone, the members of alkanone start from propanone. There is nothing like metanone. Then there is nothing like ethanone. Then I'm going to explain the reason why. There is nothing like metanone and ethanone. So it starts from propanone, then butanone, pentanone, then hexanone, heptanone, octanone, nonanone, and decanone. So there is nothing like metanone and ethanone. That is, under alkanone, metanone and ethanone does not exist. Then why? Because the the R from this side must hold at least one carbon atom. Then the other R at this side must hold another what? Carbon atom. So at least one carbon atom at this side and one carbon atom at this side, plus the carbon atom from your functional group will give you 3 carbon atoms or more. Depends on the number of carbon atoms that attach at this side and at this side. So your R at this side must hold at least one carbon atom. Your R at this side must hold at least one carbon atom. So plus this carbon atom at the middle, that is from your functional group. So the ketones contains more than 2 carbon atoms, that is 3 upward. So metanone will contain just only 1 carbon atom. So which means that it is not possible with this general formula. Then ethanone will contain 2 carbon atoms, so which is not possible with this general formula. So there is nothing like metanone and ethanone under alkanone. So they don't exist under alkanone. Now the first member will be propanone. Then R at this side and the second R can be any of these alkyl group. These are the alkyl group: methyl, ethyl, propyl, and butyl. So the R at this side and the second R at this side can be any of what? Of these alkyl group. Then under naming of alkanone, you consider your functional group in naming. So you name from the end, which will give you the lowest to the terminal carbon atom. You name your functional group from the end, which will give you the lowest to the terminal carbon atom. So let's take the first example. Now let's look at this molecular formula. To get it, let's draw the structural formula for this molecular formula. Now, if you want to draw this molecular formula of alkanone easily, consider your functional group. First, draw the structural formula of your functional group. This is my functional group. My structural formula will go in this way. C, carbon, then another bond. Then my oxygen will go with double bond. This is the structural formula for my functional group. So draw the structural formula for your functional group first. The carbon atom at this side, Then oxygen will go with what? With double bond. Oxygen will go with double bond. Then at this side, we have one carbon atom with 3 hydrogen atoms. Then attach that carbon atom. Then surround your carbon atom with 4 chemical bonds. 1, 2, 3, 4. Then bring in those 3 hydrogen atoms. 1, 2, 3. Then at this side, we have one carbon atom at this side. Attach that carbon atom. Then surround your carbon atom with 4 bonds, with 4 chemical bonds. 1, 2, 3, 4. Then 3 hydrogen atoms will come in. So bring in those 3 hydrogen atoms. So this is the structural formula for this molecular formula. So let's name now. Let's name this structure. Let's name this structure. Then, like I said, that we consider our functional group in naming under alkanone. We consider our functional group in naming. Then what is my functional group? CO. So you name from the end. You name your functional group from the end, which will give you the lowest to the terminal carbon atom. So what is terminal carbon atom? Your terminal carbon atom is your first carbon atom at the right hand side or your first carbon atom at the left hand side. So from the right hand side, if I number from the right hand side, 1, 2, 3. So my functional group will be on the second carbon atom. Then if you number from the left hand side, 1, 2, my functional group will still be on the second carbon atom. So for this structure, you can name from both ends. You can name from both ends. Then looking at this structure, there is nothing like substituent. There is nothing like substituent because our substituents are mostly alkyl group or halogens. They are alkyl group or halogens. So there is no substituent. This structure contains carbon, hydrogen, and oxygen. So which is a non-hydrocarbon. Then we recognize this structure as an alkanone due to what? The presence of this functional group CO. So the functional group of alkanone is what? CO. So this structure is what? This structure belongs to what? It belongs to an alkanone. So let's name this structure now. So consider your root hydrocarbon 1, 2, 3. So we have 3 carbon atoms. So it shows that this structure belongs to a member of alkanone with 3 carbon atoms. That would be the third member of alkanone. Methanol should be the first member, but it does not exist. Then ethanones should be the second member, but they don't exist. Then the third member will be what? Propanone, because propanone will be the one with what? With 3 carbon atoms. So this structure should be propanone. But you have to name the position of this own. Then you have to name the position of own. Then your own is your what? Is your CO. That is your functional group. The functional group of this alkanone is CO, which is your own. So name the position of this functional group. Your functional group is on the second carbon atom. So what will you call it? Propan 2-on. Propan 2-on. So this structure is called propan 2-on. Propan 2-on. So let's take another example. So let's draw the structural formula for this structure. Consider your functional group first. Draw the structural formula for this functional group. So at this side, put a chemical bond. Then your carbon atom from your functional group. Oxygen will go with double bond. Then another bond at this side. Then at this side, we have one carbon atom with 3 hydrogen atoms. First, attach your carbon atom first. 1. Then your carbon atom surround with 4 chemical bonds. 1, 2, 3, 4. So bring in those 3 hydrogen atoms. Then at this side, we have 2 carbon atoms with 5 hydrogen atoms. So first attach the 2 carbon atoms first. 1, 2. Then surround each carbon atom with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. So bring in the 5 hydrogen atoms. 1, 2, 3, 4, 5. So this is the structural formula for this molecular formula. Now, from this structure, how can we name? We consider our functional group in naming, that is CO. Your functional group is CO. Then you name from the end, which will give you the lowest to your functional group. From the right hand side, 1, 2, 3. My functional group will be on the third carbon atom. But from the left hand side, 1, 2. My functional group will be on the second carbon atom. So the best position to name this structure is from the left hand side. 1, 2, 3, 4. So my functional group is on the second carbon atom. So there is no substituent because this structure contains carbon atoms, hydrogen atoms, and oxygen atoms. So the root hydrocarbon will now be the fourth member, number 4 member of what? Of alkanone. So what is the number 4 member? 1, 2, 3, 4, 4. That is butanone. But we have to name the position of our own. So we call it butan. Your functional group, your functional group is on. Then your own is on the second carbon atom. Your own is on the second carbon, which is your functional group. So we call it butan 2 on. Butan 2 on. So the name of this structure is called what? Butan 2 on. So let's look at another structure of alkanone with a substituent. Let's look at another structure of alkanone with a substituent. Another structure of alkanone with substituent. Let's look at another structure with substituent. CH, then CH3, then another CH3. So let's look at this structure. Let's convert it to structural formula. Consider your functional group first. Consider your functional group. My functional group, carbon atom, then bond here. Oxygen will go with double bond. Oxygen will go with double bond. Then 2 carbon atoms at this side. 1, 2. So 2 carbon atoms at this side. Surround each carbon atom with 4 chemical bonds. 1, 2, 3, 4. Then fill with what? 5 hydrogen atoms. Then at this side, we have 1 carbon atom with 2 hydrogen. With 2 hydrogen atoms. 1, 2. Then followed by C with 1 hydrogen atom. Then CH3 should be what? A substituent because it is part of this CH. So CH3. Then C with 3 hydrogen atoms. So look at this structure. Let's look at this structure. Let's name this structure. Then we consider our functional group in naming. So you name from the end, which will give you the lowest to the terminal carbon atom. So if I count from this side, 1, 2, 3, 4. My functional group is on the 4th carbon atom. From this side, 1, 2, 3. My functional group is on the 3rd carbon atom. 1, 2, 3. So the best position to name is from the left hand side. 1, 2, 3, 4, 5, 6. So this time around, we have substituent from our structure. We have substituent from the structure. So we are going to consider this substituent in naming. We first name our substituent. Name your substituent before your root hydrocarbon. You name your substituent before your root hydrocarbon. So your substituent is on the 5th carbon atom. Then CH3 is methyl. So methyl is on the number 5 carbon atom. So you call it 5-methyl. Then no substituent again, so we have to name our root hydrocarbon. 1, 2, 3, 4, 5, 6. Your root hydrocarbon will be the sixth member of alkanone. The sixth member of alkanone. 1, 2, 3, 4, 5, 6. That is hexanone. Hexanone. Then the none, the on is on the what? The on is on the third carbon atom. So that's hexan 3 on. Hexan 3 on. So this structure is called 5 methyl hexan 3 on. 5 methyl hexan 3 on. So let's take another structure with a mixture of organic and inorganic substituents. Another structure with a mixture of organic and inorganic substituents. Another structure with a mixture of organic and inorganic substituents. Another structure with organic and inorganic substituents. Then a mixture with organic and inorganic substituents. So from this structure, we have both organic and inorganic substituents. CH3 is organic, while Br, which is bromine, is inorganic. Then the bromine we stand bromo. Then CH3 is methyl. Then we consider our functional group. We consider our functional group in naming. We consider our functional group. So if I count from my right hand side, 1, 2, 3, my functional group will be on the third carbon atom. If I count from my left hand side, 1, 2, 3, my functional group will still be on the third carbon atom. But when you have a mixture of organic and inorganic substituents, you consider your inorganic before organic. Since I'm considering my inorganic before organic, so I'm going to consider what? The bromine in naming. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Then let's name our inorganic first. My inorganic is on the second carbon atom. 2 bromo, comma. Then the second inorganic is what? Is on the fifth carbon atom. So 5 methyl. Then you name your root hydrocarbon. 1, 2, 3, 4, 5. An alkanone with 5 carbon atoms will be the fifth member. 1, 2, 3, 4, 5. That is pentanone. But the on is on the third carbon atom. So what are we going to call this? Pentan what? The on is on the third carbon atom. So that is pentan 3 on. Pentan 3 on. So the name of this structure is 2 bromo 5 methyl pentan 3 on. 2 bromo 5 methyl pentan 3 on. So we have come to the end of today's class. Remember to subscribe to Royal Learning Channel to learn more about naming of organic compound and organic chemistry generally. Then share this video with your friends, comment and like. Thank you. Bye for now.